All right, so this is just more properties of parallelograms. There's a lot of details about parallelograms that you need to make sure that you know, just so you can identify missing pieces. So this first one, theorem 6.6, says if a quadrilateral is a parallelogram, quadrilateral is a parallelogram, then its diagonals do something to each other. Any guesses what that something is? If you look at this picture right here, they're saying these two lines are doing something to each other. Anyone think they know what that is? They bisect. So if it's a parallelogram, right, if opposite sides are parallel, then those diagonals are going to bisect each other. So for instance, if I just drew any old parallelogram here, as long as we know these are parallel and these are parallel, then we also know that these two pieces would be congruent, right? Bisect means cut into equal parts. And we would know that those are congruent. Notice that you have one marking on the one and two markings on the other. It's not that all four have to be congruent, okay? It's that the parts of the one have to be congruent and the parts of the other one have to be congruent. So if that's the case, how would you set up that example 4 to find A and B, first of all? Set what equal? Right, so we would say A equals 2B minus 8, okay? And then your other one would be A plus 2 should equal B, right? So these two parts are congruent and these two parts are congruent. Both of those have two variables, so you're going to have to just do substitution. Do you have a preference? Do you want to plug this into the bottom one or plug this into the top one? You can do either. Okay. I'm just going to plug this in because it's no distribution then. So it would be 2B minus 8 plus 2 equals your B value. So take away the B, you're left with just a B on the left side, and then negative 8 plus 2 is a negative 6. I'm going to move that to the other side. So B would equal 6 here. And then if B is 6, now you can just plug that in up here. So A is 2 times 6 minus 8, or 12 minus 8, which is 4. Okay, so we know our A is 4, our B is 6. They want to know the lengths of HJ and IK. Can anyone tell me how long HJ is? HJ would be 8, right? Here's the thing. You don't have to plug in, like, to the B right here. You don't have to plug that in. We know A is 4, and we know it's bisected, which means this one's 4 also. So you don't have to do all the plugging in. HJ would just be 4 plus 4, or 8. How about IK? How long is IK? That would be 12, right? This is 6, so this one has to be 6 also. So 6 plus 6, or 12, would be IK. Okay? So if it's a parallelogram, diagonals will bisect each other. Okay, next theorem. And this is really the last of it for this first lesson. This one's pretty short. This one says, if 3 or more parallel lines cut off congruent segments, so segments of equal length, on one transversal, then they're going to cut off congruent segments on the other transversal as well. Or any other transversals as well. So if you look at this picture, basically what that's saying is, because I know the lines are parallel, okay, so because they are parallel, if these two, AB and BC, are equal, so if AB is congruent to BC, then it will be true that DE is congruent to EF, okay? I think where a lot of people get confused on these ones is they try to make these two the same length, and that's not the case. It's the two that are on the same line that will have the same length. So if this is like 10 and 10, and we said this one's 11, then this one would have to be 11 also, okay? So it's not the ones across from each other, it's the ones that are on the same line that would be congruent. Does that make sense? So like this, for instance, okay? Example 5 here. Here's what you know. We're gonna say you know that AB equals BC, which equals CD. Okay, and then we know that EF has a length of 2.5, and I want to know the length of EH. Can anyone tell me what that would be? Yeah. 7.5. How'd you get it?
Because we know A, B, C, and CD are equal, that means E, F, G, H will be equal.
Right.
Add 2.5 to itself, then do that again.
Yeah, so we were told this, right? AB equals BC equals CD. So it doesn't look like it. It's not drawn to scale. But pretend those three are all the same length, okay? Because those are the same length and the lines are parallel, then that means that all of these are also the same length. And they tell us that this piece of it is 2.5. Now, just be careful with this, because a lot of times people go, oh, E, F, G, and H. So I need to do 2.5 times 4. But the 2.5 is this length, and there are 3 of those. So just be careful that you do it times 3. 2.5 times 3 would give you 7.5. Okay, so EH is 7.5. Okay. One last thing. What about this one? Okay, so if I tell you that this has a length of 5, a length of 5, and I tell you FE is 4, can you tell me what FD is? What is it? 8. It would be 8, right? So if I know this is 4, then this has to be 4 also. So then the whole thing, FD, would be 8. Yeah, Chloe.
If on the question before this, if like A, B, and C, D were congruent, does that mean like all of them are, like all of them on the other side are congruent? Or just the...
No, because you could, like this picture does a good job of showing that it wouldn't necessarily be that way. You could have like this setup, right? These are parallel. It could be that these two are congruent, but this one's definitely shorter than that, right? So just because 2 are doesn't mean they all are. They would have to tell you that all 3 are congruent, and then you could say all 3 on the other side would have to be congruent as well. But if, like, say I had it something like this, forget that this, like, that one's not congruent, that still means that this piece is the same as this piece. It just means this one is not. It's a good question. Any other questions on that?